My name is Aidan Choo, and this is analyzing the effect of time pressure and constraints on chess performance. The purpose of the study is to study the effects of different variations of time constraints on the performance of chess players. The study was done by collecting data from 4 time controls of chess: bullet, blitz, rapid, and classical. Using a metric called centipawn loss to determine the quality of play, the study shows the relation between move quality and the amount of time that the player spends. Classical being the longest time control and also the control group. A chi-square test was run on the data, which supported the hypothesis that a longer time control resulted in better moves made by the player. Compared to bullet, classical chess matches showed results of moves that were nearly 3 times better in terms of centipawn loss. Data didn't show much variation across different levels of play, which were divided into intervals of 200 based on an ELO system that chess uses universally. Further studies are to be about the different factors that may play in move quality, such as opportunism, luck, and the difference in rating between the two players. The modern day presence of time pressure obviously has greatly influenced the performance for various subject areas. In the case of chess, where time is such a prominent part of the game, there are set time controls that denote different set amounts of time allocated to each player for the game. They have names like bullet, blitz, rapid, and classical, classical being the slowest and bullet being the quickest. The popularity of faster time controls in competitive play went up, so there came the decision to separate the ELO, which is a quantifiable rating system that compares the relative skill between players, for each time control. In particular, chess also has been found to use 2 different types of skills, one being the longer term and slower logical visualization process, and the other being rapid pattern recognition. These 2 skills blend both fast and slow processes, making chess a fairly suitable choice to conduct a study. Of course, chess acts as a good measurable example where the amount of time pressure can be directly related to both the skill and move quality of the players. Using chess as an example to learn the effects of time pressure on both decision-making skills and efficiency can provide further insight into the role that time pressure plays in more general areas such as standardized testing or even deadlines in a workplace. Centipawn loss measured the quality of a move relative to 1/100th of a pawn. A pawn in chess is considered 1 full point, and thus a high centipawn loss of 100 would approximately equal about the loss of an actual pawn in game. Centipawn loss is an accurate play quality index, and also centipawn loss is easily usable as data, which makes it convenient for comparing games. The already instated ELO system that chess uses is also convenient to use to divide the groups that are being compared, as the same ELO system is universally used by all chess players. The graph below shows the reliability of the ELO system compared to the quality of play. In order to determine the performance of chess players in various time controls, the database on regular chess sites such as lichess.org, which holds the database of thousands, perhaps even hundreds of thousands, of chess games with data on rating for each player. The players include a wide range of players from 1600 to over 2800 rating, which covers a big enough pool to be representative of all chess players. Time controls will be divided into groups of classical, rapid, blitz, and bullet. By randomly sampling games and recording the performance, time spent on certain moves, as well as the centipawn loss to determine the quality of moves, each player's respective ratings for each time control, as well as individual performance will be compared. With 10 players from each rating category and 4 values for each time control for each player, there's enough data to run a chi-square test and a linear regression test to determine the relationship of the data points, thus proving or disproving the hypothesis. Alright, the null hypothesis is that the slope is 0 in the linear relationship comparing time controls to quality of play. Regardless of time control, the player's quality of play will be the expected value of their average quality of play. Meaning that across the different time controls, a player will have the same rating or quality of play that their average quality of play is determined to be. The alternative hypothesis is that the slope is less than 0 or negative in the linear relationship comparing time controls to quality of play. Time control affects the player's quality of play and thus varies depending on each time control. The control group is the overall playing quality across all time controls, which was the average of all of the ratings, and the independent variable is the games in classical, rapid, blitz, bullet, the ELO of each player. The dependent variable are the playing quality of each player, which is the average centipawn loss data that was collected, and the trials are the 10 players of different rating with each of 5 centipawn loss ratings for each of 4 different time controls and 1 average overall. So each row is a new player, and data for 10 players was collected. After a chi-square test, a goodness of fit test was ran using the different experimental values, the values for the 4 different time controls, as observed, and the average values for each player as the expected value. The resulting p-value was significantly low. The results of the goodness of fit test disprove the null hypothesis, and this proves that time control does affect play quality. As graphs demonstrate, when using the data collected from the online database, all of the linear regressions modeled had negative slopes. Even the highest and lowest rated players showed a clear negative slope which support the alternative hypothesis. The next slide shows a regression of all 10 players' centipawn ratings. The slope versus rating graph shows that there is not much of a correlation between actual rating itself and this trend of play across time controls, with a low correlation coefficient, or squared equals 0.139, compared to the higher values in the other regressions. Therefore, across the different ratings, there wasn't much of a correlation, so that this trend was universal across all ratings. The results of the data analysis proved the hypothesis correct. The chi-squared goodness of fit test results show that time control has a statistically significant effect on play quality in chess. The linear regression test also shows a significant result in that each player has a clear negative trend when going from faster to slower time controls. The trend is universal across almost all ELO, and there's no statistical significance in the slopes of the regression compared to rating. Further study could be done by analyzing other factors that might affect playing ability, such as environment, which is comparing online chess versus over-the-board chess, the rating difference between each player, an opponent, and etc. Looking at closer details could include individual time spent on each move compared to the quality of that move in the game, which would be a lot more detailed. And this overall conclusion can be extended to other fields and studies involving simple tasks or even more complicated ones that involve time. Though it cannot be universally said that less time means worse performance, the study suggests that there is a strong correlation between the two. Thank you.